I know that it's there, I just haven't looked at them.
Okay, so we're going to start out fresh. Chapter 2, Polynomial and Rational Functions. All right, Section 1, called the quadratic functions. So we start out with the definition of a rational function. So you can fill in your sheets as I go. I don't know that I'll give you everything you need. Some of those, I'm going to highlight the key points and what you need to know to solve your homework problems. So you may have to also, for homework, finish the rest of the sheets for the things that I don't go over if there are some questions there that you have. Okay, so it starts with this idea of the definition of a rational function. So let n be a non-negative integer, and let such that a of n is first, then a of n minus 1, so on and so forth, all the way to a sub 2, a sub 1, a sub 0 be real numbers. So basically, and a sub n is not going to be equal to 0, so you get a function. The idea is they want you to list your function from the highest exponent down. You know, they use a lot of these symbols that confuses you guys. And, you know, if I have something like this, let me get it. This thing keeps. Okay, so if I have x to the 4th plus 2x cubed minus 3x squared plus x minus 2. All this idea, this definition is letting you know is list your terms from the highest exponent down. Okay? And this is called the polynomial function with the x degree of n. So the idea is that when we talk about degrees of polynomials, you're going to use the highest exponent. So because this particular one that I drew has an exponent of x to the 4th, this is a 4th degree polynomial. Okay? The idea is if you have, well, I think I put it on the next one, so let's see. A constant function, f of x equals a, is a polynomial of 0 degrees. That's because you don't have a variable there. All you have is a constant number. And so this is our constant function, and it's going to look what? Something like this. It doesn't matter what the a is. Let's pretend the a is negative 3, so it's going to look like this. F of x equals negative 3. Okay? That's a 0 degree polynomial. A linear function we're more familiar with. So a linear function can be any line. And so let's draw the identity function. F of x equals x. In this case, x is raised to the 1st degree, and so because it's to the 1st degree, that would be a 1st degree polynomial. So linear functions, any graph of a line, any function of a line is going to be a 1st degree polynomial. And we also know that when we put it in slope-intercept form, we have f of x equals mx plus b. And this identity function can be written the same way. This is just saying f of x equals mx plus b, where the m is 1 and the b is 0. Okay? So any linear function, mx plus b, is a 1st degree polynomial, and m is always the slope, and the point 0, negative b is your y-intercept. That's not too bad. Okay. So now we get to the section that we're on, the definition of a quadratic function. Okay. Let a, b, and c be real numbers, and a is not going to be equal to 0. That's because if a is 0 here, then what do you really have? All you really have is a constant function, because those are both going to drop out, because 0 times anything is going to be itself, and you're just going to have f of x plus c. So that's why they exclude that, because if x is equal to 0, then you don't have a quadratic function. What you have is a constant function. And the function is given by the notation f of x equals ax squared plus bx plus c. This is called a quadratic function, and this is a 2nd degree polynomial because you have an exponent of 2. Okay? And you know by now, you've done enough math to know that the graph of a quadratic function is called a parabola. So anytime you graph a quadratic function, you're going to get a parabola. Now a parabola is either going to go like this and open up, or it's going to look like this and it's going to open down. But either way, any quadratic function you get is going to give you a parabola. All parabolas are symmetric with respect to a line called the axis of symmetry, or simply the axis of the parabola. So no matter which one I draw, there's going to be a line down the center, and the one I drew here was just the y-axis. But it doesn't have to be the y-axis, okay? But the one I drew was simple, so it is the y-axis. And basically, it's the reflection about the y-axis. So, for example, if I have a parabola that looks like this, let's see. Now my axis is down there. But all of the parabolas are going to have an axis of symmetry. Sometimes it'll be on the y-axis, but not always. Okay. The point at which the axis here intersects the parabola is called the vertex. This should be mostly reviewed at this point, right? So that point there where your axis of symmetry crosses or intersects your parabola is going to be called the vertex. And if we were looking at it the opposite way, there's my axis, and then there's my vertex. And by and large, the vertex and the axis of symmetry are going to be determined by what we do to the basic function. So we learned in the last chapter that f of x equals x squared that's the most basic quadratic function. Okay? So what we do to that function will determine where our axis and our vertex go. So for example, if we had something as simple as a plus 3, what does that do to my function of x squared? What does it do to my quadratic function if I add a 3 onto it? It's a vertical shift, right? Adding it on after the function. It's a vertical shift. Okay? Yeah. The number a in front of your x squared is either going to be positive or negative. Here it's a 1. We don't write the 1 because it's understood, but so it's a 1. It's a positive 1. That means it's going to open upward. If that's a negative number, it's going to open downward. So yeah. So it's just going to look like this. And what is going to be my axis of symmetry? What's my axis of symmetry on this particular? The y-axis is my axis of symmetry. Because nothing changed except for that we vertically shifted it up. What's my vertex going to be? 0, 3. That's all. All right. Let's take another one. Oh, f of x equals x minus 1 squared plus 2. Okay. What will that do to my quadratic function? What's that going to look like? This is all reviewed from last chapter, right? What's this one going to look like? It's going to move left, because my horizontal shift is the opposite of my sign, remember? I'm sorry, you're right. Okay. It's the opposite of the negative, you're right, I'm sorry. So it's going to move right 1, and then it's going to do what after that? Up 2, so let's call that 1, and then up 2. So we'll go like that. And is that going to open upward or downward? Up, because there's a positive coefficient in front of it. It's positive 1. It's not written, it's just positive. So here, what then is my axis of symmetry on that? On this function, what's my axis of symmetry?
X equals 2.
This is the point 1. I'm sorry, I didn't draw it really well
Y
through here.
equals
I'm
2.
sorry. No, it's going to be x because it's a vertical line. You're right.
X equals 1.
X equals 1. That's going to be my axis of symmetry. And then what's my vertex going to be, Ben?
1, negative 1, 2.
1, 2. Good.
Yeah.
Okay. Okay. The standard form of a quadratic function. The quadratic function given by f of x equals a times the quantity x minus h squared plus k. A equals, sorry,
Oh, it's stupid.
a does not equal 0. I don't have that symbol, I meant to write that in afterwards. Okay. And again, if a is 0, the reason we have to limit that, if a is 0, then a times anything is going to be 0, and then all I really have is a constant function. So that's why they have to limit that. And you'll see that a lot in the book. So going forward, they're always limiting your domain. Okay, they're always limiting what you can do so that it makes sense. And when it's written like this, it's considered in standard form. It's the graph of the function is a parabola whose axis is the vertical line x equals h. Okay, so if it's in this form here, the h will be equal to the x value, and that will give you your axis. And the vertex is going to be the point hk. So if you use your whatever numbers you fill in there is going to be your vertex if it's in standard form. So as you can imagine, we're going to have to get some of these in standard form. If a is greater than 0, we've already discussed, if it's positive, then it's going to open upward. If it's negative, it's going to open downward. Okay? So let's see. Let's come up with some. Okay. All right. Identify the
H
vertex.
can be positive too, right?
What's that?
H can be positive too if it's in that form. I know it had it negative, but can H be positive?
Can this be a positive number?
Yeah, can it be plus H or
It is. If it's plus h, if it's x
is
plus
it
h,
still
what's that tell you?
that just it shifted over to the left?
Okay, but if this is in standard form, that means that whatever your h value is going to be negative h is going to be your vertex point.
Yeah.
Okay, so you're just going to do the opposite. Okay, and the same with k. If you had an equation that ended up with minus 3, that would tell you that your vertex point is 3. Okay, because it's standard form is plus. So if your number came up to minus 3, it's going to be the opposite of your vertex. You'll see what we do. We'll do one here. Okay. All right.
Yeah, I know. I hated H.
So identify the vertex and the x-intercept. So let's start by just writing the function of what a standard form quadratic is. And what is it? Read it. A. Okay. So in order to be able to find the vertex and the x-intercepts, we're going to need to get this in the standard form. So is this in the standard form now?
No.
No. Okay. So how do you think we're going to do that? How are we going to get that in the standard form? Well, what do you have now? You do have a k. You have something squared, but then you have this in the middle. So somehow you have to combine these.
Oh, please
Do you remember? Tell me what. We're bringing some things back.
No,
We're going to start bringing some things
I
back.
hope we're not doing what I think we're
How,
doing.
well, it's not that hard. What do you think we're doing? Okay, but the factor, you could do it. You could say f of x equals x squared plus 3x plus 1/4. But can you factor that?
No.
You could do anything you want because it's not basic algebra. I can take an x out and say x plus 3, but that's not going to get me in any standard form because I want a squared on it.
Multiply the equation by 4.
All right. Do you remember from algebra 2, the end of algebra 1, process called completing the square?
Oh.
Yeah, but my calculator can do that for me.
Well, wonderful.
I
But you should know how to do this as well. So how am I going to do that? How am I going to complete the square?
That was stupid. I forget how to do
Oh,
it.
come on, it was fun.
Oh,
That
come on,
was-
this is the biggest. I never
There
remembered
was a
this.
4 AC. That's all I remember.
All right. I want to be able to add something onto the end of this so that I can factor it to an even square. Okay. To do that, all I'm going to do is take my
I had
expression
it
here.
memorized.
I'm going to divide that in half. and then I'm gonna square it. That's all I'm gonna do. I'm gonna divide that in half and then square it. So, that's all
It was
there is.
like you put it equal to 0 or something?
Well, right now, all I'm gonna do is
I bet.
divide it in half and square it. So, what is half of 3? Alright, it's just
3 halves.
3 halves.
Yeah.
And then we're gonna square that, okay?
9/4.
And then, it's gonna be 9/4, so f of x equals x squared plus 9/4. Okay, now,
Oh, wait, you
if,
didn't have to square the 1/4?
I'm not done with that yet, I'm not done.
Oh.
All I'm doing is this part here, I'm just doing this middle part here to find, what do I need to add on to this? So this plus 9/4 is what I'm gonna need to add on to this to make that factor, right?
Okay.
Okay, but I still have a 3x, because I haven't done anything with this. That's still gonna be there. And I still have my 1/4. But what have I done? What have I done from here to here? What did I add to my equation? What did I do from this step here to this step here? I still got an x squared, I still got a 3x, I still got a 1/4. I did what?
9/4.
I
Yeah.
added 9/4. Well, can I just add 9/4 to something?
No.
No. So to make that equation even, what do I have to also do?
Add 9/4 to the other side.
No. Okay, but that's not what we're gonna, that's not gonna help. You don't want to go into that.
But that.
If I have,
cheated.
look at it this way. If I have 5 and I add 9/4, what could I do to that to keep this still equal to 5?
Minus 9/4.
Right.
Why?
Because that was still going to be 5. It'd be the same equation. So if I can take a minus 9/4 here, that's the same
But
equation.
yeah, then why did you do that in
You're
the
gonna
first
see.
place?
You'll see.
No,
Well, it's
I
not
won't.
pointless. It's going to let this square. You'll
That's
see.
pointless.
All right.
But then you just get x
Watch
squared
this.
plus 3x plus 1/4. You already had that, so I feel like you're doing
Well-
a whole boatload
well,
of
I-
extra work.
Well, no, because I'm not going to. I could now. I could just subtract those back out and back to the beginning, but that's not what I want to do. Because that's not going to help me to get that back to the
Then
beginning.
what are you trying
What
to
I'm
do?
trying to show you is this thing is the same as 5. And so this whole thing is the same as this whole thing. So adding and subtracting makes it so that I didn't change the value of my equation.
I see
Okay,
that.
all I did is
There's no-
break them. There is, so you'll see. All right,
Oh,
so f of x equals x squared. Addition's commutative, right? I can add my 3x
Go ahead.
plus my 9/4 plus 1/4 minus 9/4. So you see that I'm okay there, right? Nothing crazy's happened yet, right?
Trying to get a -2.
All right. Well, now, again, this is commutative. So what I can do is, I'm just going to look at these for a minute. So I'm going to look at this. X squared plus 3x plus 9/4.
Oh. I see what you're doing now.
Oh, wonderful. Okay, I haven't changed anything. All I've done is use my associative property to associate them the way I want, right?
Yes.
Well, now what do I do this? Can I now factor this?
Yeah.
How do I factor it? What's it going to be?
Okay.
Listen to that. We want it to be an even square, so we know it's going to be, what's the first one going to be?
X plus.
X and plus. So now I got to figure what times itself is going to give me 9/4.
3 halves.
3 halves.
My word.
And I can prove that to you, because look, x plus 3 halves,
So done with this.
it's really not that bad. Look,
Why am I
6
stupid?
minus 3 halves. So you could use
Why
FOIL.
minus?
What?
Plus.
No.
Oh, it's plus. Yeah, they're both plus. I'm sorry.
Hey!
It's like,
Both of you were saying no to
Yes,
me.
they're both plus.
No.
Right.
Okay, so what? So x times x is x squared plus 3 halves x plus 3 halves x plus 9/4. And so what is 3 halves x plus 3 halves x?
3x.
6 halves x plus 9/4. 6 halves is just 3.
Oh.
So you can see that that's the same, so that squares it. Okay. All right. So, but then I still have these. What am I going to do over there?
Minus 2.
What's that?
Just subtract it.
Right, and so that was pretty simple. So what's my answer going to be?
minus 2.
What?
It's a negative 2.
All right, well, you want to step ahead. I like to do them in one.
Oh.
Well, that's fine. 9
My
quarters
brain
minus
doesn't
1 is
function.
8 quarters.
See, when I see
The
it-
smallest
no.
number, so which is it's negative 2, right?
Yeah.
Is that what you
That's
said?
just what I see.
All right.
I don't see 8.
Okay. So now
So I have $2.
now I have f of x equals x plus 3 halves squared plus negative 2. So now I now have my quadratic and standard form. Well, that's really cool, because now what do I know? Once I know my standard form, then what do I know?
The point is.
I know 2 things. Right, you know your vertex now, right?
And you know how to shift it. Yeah. You do.
Well, hang on a minute.
I'm going too fast.
What's that?
I'm going too fast.
What's my vertex going to be now?
3 halves,
Okay.
negative 2.
It's my standard form. Well, my initial is a minus there, right? In standard form, it's a minus there, right? So I didn't write it out there, but it's actually plus. The same as plus minus negative 3 is minus 3 halves. So it's actually the opposite, right?
Oh, it's negative 3 halves.
No, it's fine.
No, it's positive. I'm just showing you why it is. Because you're minusing the minus. Because you have a plus here, but the standard form is going to you need a minus.
Why?
Well, that's the standard form. So if this was minus 3 halves,
Stupid.
you have to turn it into a plus, which is a positive, and then you subtract it around to be a negative. That's what I was telling you before. When you asked about when we started, if it's a plus or a minus, what's the difference? So because it's a plus, you're okay.
It's a negative, it's still positive?
If h is always going to be a positive number, but what you're going to do to the h here is either going to be plus or minus. So I was just showing you the step that minus a minus is giving you your plus. That's how you got your vertex.
Then is the h ever going to be negative? You're never going to have a
Yeah.
negative.
If your H is positive, then it's gonna be negative. Correct? If it's in standard form and it says H
This
minus
is-
or X minus H, and you have a positive number, it's gonna be minus H. But if you have a negative number, then it's gonna be positive.
I don't want to do
So my question is, so what is my vertex here? That's what I'm getting to with the whole thing.
I
What's
don't know anymore.
well, you got your numbers. Is this positive or negative? Is all I'm really asking you.
It's positive. There's no
You're
trick, right?
Still, yeah, no,
It's
you're
negative.
Still,
It's
right, but I'm
negative
trying to
because it's gonna
get you to
open
figure
up.
out why.
Oh.
Because it's going to.
Open up.
Yeah, but
I
I mean, let's pretend you didn't have a graph and you couldn't see it. Yes, you're right. You could graph that. You'd know by whether or not it opens up, whether it's positive or negative. Yes,
I'm
that's true.
Because, well, I'm gonna.
What I'm trying to say is, here's your standard form as a minus. Okay. So when you get to here, you have to turn this into a minus. Okay. So think of it this way: f of x equals x minus what will give you plus to make this whole thing plus 3 halves. 3 halves, right?
Sure.
Does that make sense?
Yeah. I guess so.
Oh, so everything is negative.
It would. So what number would I have to put in here to turn this into? So if I want a minus, what would I have to put in here to make this plus the whole thing plus 3, 2? I'd have to put a minus, right? Because it's minus a minus is giving us a plus. Does that make sense here? That's why my actual h is a negative.
Oh!
Are you getting it now?
Oh!
Does that be a real like the light turned on, or you're?
Yeah, I get it. Oh!
So that's why it's a negative.
Yes!
Okay.
And if it was, so if it was a
That's why
positive,
what I'm
then
doing
that
is I
would
wanna
be
write-
negative. Okay,
All right.
I got that.
Now
Okay.
make sense?
Yes.
All right.
It's not gonna be good.
I was so confused.
Okay. So we got it now.
Yeah.
Yeah.
All right. Wonderful. All right. Now. Okay. Minimum and maximum values of a quadratic function. So a quadratic function is either going to have a minimum or a maximum. It won't have both because it's a parabola. If it opens upward, it makes sense that it's going to have a minimum, right? Because the vertex is at the bottom. The minimum is going to be the vertex. The minimum or the maximum will always be the vertex. Okay? So whether you have a minimum or a maximum is going to depend on whether your coefficient of your quadratic is positive or negative. So if your a is positive, it's going to open up, and if it opens up, that gives you a minimum. If it's a negative number, then it's less than 0, then it's going to open downward, and it's going to have a maximum. So the vertex will either be a minimum or a maximum, depending on whether it opens up or down.
Those are the same thing, minus b over c.
This tells you how to find that value.
Oh.
Okay, this is going to tell you how to find that value, and then whether that a is positive or negative will tell you whether or not that value gives you a minimum or a maximum. But it won't have both, it will only have one. So from our prior equation, we had this. This was our prior equation that we just had. You don't have to raise your hand.
Okay,
Go ahead.
well, I just don't understand why they're the same equation. Like,
Because it's the same numbers will give you your answer. It's just telling you that they can't both be a maximum and it can't have a maximum and a minimum. This number is either going to give you a minimum or a maximum. It's going to give you the vertex is what it's going to give you.
okay.
Because the vertex is going to be the minimum
So
or
that's-
maximum, right?
That's the equation to find.
A vertex, which will be a minimum or a maximum. Good.
Okay.
So, from our prior equation, we have f of x equals x squared plus 3x plus 1/4. And we know a is 1 because it's not written there. And so because a is 1 and because a is positive, we know we have a minimum because the graph's going to open upward, right? All right, so to find what that vertex is or that minimum, we're going to do minus b over 2a. And then it's simple enough. So, Ben, how am I going to fill that in?
A is equal to 1, so 2 times 1.
Okay.
B is 3.
B is 3.
Where's the quadratic?
So what do we get?
It's coming eventually.
Okay. So now what am I going to get, Ben? What am I going to get here?
I don't know what that is.
Negative 3 halves.
Negative 3 halves. That was where and that's going to be our minimum. Okay? And if we go to the back page, you'll see the negative 3 halves. Negative 3 halves here.
I'm positive it's gonna pop up somewhere. I know it.
What was that?
That's our negative 3 halves there.
I don't want to know what that is. Quadratic models.
Okay?
Oh, I'm going to hate my life this year.
Don't get ahead of yourself. Okay. So easy enough to find the minimum or the maximum value?
Yep.
Okay. Alrighty. Now, you could, if you wanted to find both coordinates of your vertex, so this is negative 3 halves, that's going to be your x coordinate. Okay, that's going to be your axis of symmetry. So x equals negative 3 halves will be your axis, that x line. And then your vertex will be on this line at that y value. So my y value is just f of x. So if I put negative 3 halves squared plus 3 times 3 halves plus 1/4. I could solve that and easily enough. What's negative 3 halves squared?
Positive 9/4.
What's this? 3 times 3 halves.
9 halves.
And then again, you could solve that. Let's make them all fourths, make that easy. So 18 and 9 is 27. 28 over 4.
Why?
Y.
Yeah, why is there a 7?
That's the y coordinate.
But that wasn't our vertex on the last one, so let me double check here. Did I write the right numbers in? Negative 3 halves squared is
Isn't it
9 halves.
9/6? Not,
9 halves plus
or no.
9 halves. It's 18 halves. 18 halves is just 9. Wait a minute. 3.
What did I do wrong? that one's not negative. Shouldn't it be negative 3/2? And it would end up being negative 9.
Oh, I got you.
Yeah, I did
This
something
here,
right.
this is negative 3/2 when I put this in here. You're right. So there's my negative. So now it's minus, or minus. So minus 9, or 9 minus 18 is minus 9 plus
I'm
1
going to get a negative 2.
is
Okay. Minus 8 fourths.
minus 8 fourths.
Two. Minus two.
Oh, is a negative 2 right or no?
Yeah.
And negative 2 was our. I'm sorry about that.
I did it. I helped.
See? You could do this.
Sort
Okay.
of.
All right. Easy enough to find the vertex for minimums and maximums. All right. Height of a ball. Okay. So the first thing we do, if you want to turn your books to page 97, 97 is this question. And you'll find on 97, it gives you a little picture on number 63. Okay, and this is I just want to work this one in class. So, height of a ball. The height y in feet of a ball thrown by a child is given by y equals 1/12 x squared plus 2x plus 4, where x is the horizontal distance in feet from where the ball is thrown. So, A, use a graphing utility to graph the path of the ball. So you can do that real quick on a graph. That'll be easy enough for you. You're just putting your function in and drawing a picture.
We're graphing it?
Yeah.
Yeah, let's do it. Let's have some fun.
So,
Be mathletes.
so we know it's going to open up.
I did something wrong.
Oh, did I not put the negative in here? I'm sorry.
No, I did
Negative there. Because it's going to open down, right? The paddle ball. If you shoot a football or a baseball up, it's going to be down.
I did something
A,
wrong.
but it, does yours look like it?
Yes, what did I do wrong?
It's like it doesn't have the full thing, and I hit zoom data and it didn't do anything. It just kind of moved out.
Windows zoom.
Did something wrong.
So on my x-axis, I only want to look at anywhere from 0. So let's say 0 to 500. And then let's look at it.
So I got 9 hours of sleep last night, and I'm still
serious?
I'm still tired. though.
Really?
Yeah.
Oh my gosh, I'm
I
sorry.
slept until 7.
If you use 0 and 50, give you a little better of a window to see it. So he's throwing the ball up. It doesn't-
Oh, there it is.
For your minimums, you want zeros because you're not going to have a negative. Okay. So you're just throwing the ball up.
A lot better.
I mean, it looks like this, right? Something like mine. All right. That's the easy part. I mean, that's just putting it into a graph.
That's fun.
How high is the ball when it leaves the child's hand? So in other words, where does the ball start? How high off the ground? And so a hint is just, you're just finding y when x is 0. Okay? So that's all. So y equals negative 1/12 0 squared plus 2 times 0 plus 4.
That's cool.
That's easy enough, right?
Yep.
So the ball starts off 4 feet off the ground. Okay, so now that's okay. The next part gets a little trickier. So now what is the maximum height of the ball? So if I throw the ball's going to work like a parabola. It's going to go up, and then eventually it's going to lose speed, and it's going to come back down. So it wants to know at its highest point, how high, what's the maximum height of the ball? That's just finding a maximum. So how are you going to do that?
Minus B over 2.
good. That's all it, minus b over 2a. So figure that out. What is it?
Which one is B?
So 0.032.
There's your function up there. I apologize, that was a negative. I forgot to write it in my equation. So.
Negative 0.032 on the bottom times 2, and then the b would be
Sorry. So what's the b?
1. B is 1.
B is what?
1.
In the equation, what's your b? What's your coefficient in your second term in front of the x? In your equation, in your book there.
My book?
You're on page 97 of the book, right?
I
That's
got
the book.
1.
What's that?
B is 1.
No. You're on, go to 97, pick number 63.
Oh!
It's minus 12,
That's where we are.
right? Am I not right? I'm not.
Okay. I see what's going on here.
Okay.
Alright.
So now what's, now you can get it?
I was doing the wrong, I was doing the thing, the
So
example.
b was 2 over 112.
I was wondering why you had 112. I was like,
Oh, I was right. So one of them is the x value is 12.
Well, hang on. Well, you're very close. You're very close. So you figured out how to work this out, right? This
Yeah.
part. Okay. And I'll make sure Ben gets there.
what? I'm getting there. Close for? Okay. I see the graph now.
Okay.
Yeah, I know. I was on.
So what do you got? What's your answer?
What do you mean?
All this. Did you get an
Oh,
answer?
I was making a graph. I don't know.
-2. You just multiply by the reciprocal, right? 12 over 1.
1, negative 1, 6. Oh no. No! No. I'm doing this on my own.
Wait,
You had to
what?
multiply that by 2. You had to multiply that. 'cause
Oh
you
yeah,
had
I was like, wait,
two.
what?
Sorry. So this one was negative 1, 6. You had the right answer, but the ball starts from the ground, because that's where he starts throwing it. So my maximum is 12 plus where he started from, which is 4. So 16 feet is the maximum height of the ball. Because
Oh,
12
I
was
thought you
my
wanted,
thing,
like,
but
the point, okay.
it is the point, but the point starts at 0, 4. That's where you start, so that you're 12 higher than that is your maximum.
Gotcha.
How far from the child does the ball strike the ground? That's just a 0 for my y value, okay? So if I took this in, I took my original equation and put y equals 0 and solved it for x, I'd use my quadratic formula, and I'll get some crazy number when you do the square root, and it comes out,
Quadratic formula.
So
it comes out to 25.86 feet ahead, okay?
So the quadratic formula is coming. Do I need to prepare myself for
You
that?
can put it in your calculator,
What was
it gives
that?
you, it estimates it.
It's
All right,
like,
so you have on your back of your sheets that you fill out today is your homework for tomorrow. Please have it filled in when we come in to go over those. It's on your. If they're not they're not the ones online, they're not the ones up there. I picked different ones. I wrote them on your sheet. So,
I'm following the
and I
sheet.
made less problems than what was up there. So,
yes.
okay. So good job.